Should we wait someone else? No. Okay, let's do the third one. So let me redraw the picture that we have. So we have 1 and 2/3 here and 0, and then our graph increase convexly to 1/3, then increase concavely to 2/3. Here maximum, and then it goes down to 1. And the question is which restrictions we should set on A and B such that the maximum price is in 1. So that was before. So we know that the maximum point here is in 2/3. So what will be probably change if we will add A and V back. So now our equation is and then n equals to 1 minus x. So the graph will be different, right? And we need to understand how different it will be. So then, firstly, what we need to do again, let's say.
We should find first and second derivatives.
Yeah, so that they need to find the first the maximum point, right? So okay, let's take the first order derivative. It was, what is this? This is A, then plus 2x y minus x v, and minus vx hat squared. So then we have 2x minus 2x squared v, so in total it will be minus 3x hat squared. Yeah, so it looks like the same, a bit.
And where are the v's in the first? Well, in the second.
Yeah, it's here. I forgot it. Let me draw it. like that. So again, we can take 1x out. 1 minus 3v x.
And in the second component, shouldn't we have v?
Yeah, you're right. So then probably we can take the, sorry, the v out as well, right? It will be x at v 2 minus 3x. So we can see that it looks like a bit similar. So then we will equalize it to 0. What x hat we can find? We need to solve the quadratic equation, right? Okay, then let me rewrite it in quadratic form. So it will be 3v x hat squared minus 2v x hat and minus a equals to 0. So let me divide it by 3v firstly. Since v is positive, I can do it. And then what I should do next? Yeah, who remember the squared equations from school?
To find the determinant?
Yes, so then what is this? This is squared 2/3 minus 4 times. Then, okay, 4 I can take out. Yes, and then for existence of the solution, that's probably unnecessary. So, and x will be 2/3 plus minus. Well, then let me take 1/3 as well. So can you follow me? So I will take 1 over 9. I will multiply by 3 and 3, and 9 take out. So it will be 2/3 everywhere. So it will be 1 over 3 in total because we divide by 2 of them. And then it will be 1 plus minus square root from 1 minus 3a over v. Yes, so
Shouldn't we have the plus sign in the determinant?
Yes, because if we have a plus in determinant, that's
It will
true.
be plus.
Yeah, my bad. Plus everywhere. Well, and then the need to find which one is more good for us. So then we need to find such that x is
I guess
greater than 1, right?
if our x is supposed to be positive, we shouldn't take into account minus root.
Yes, so then minus root will give us something negative, right? Since they're plus. So then we need x to be positive. So then we take the plus root. So that will be 1/3 plus 1/3. And then we want to have this maximum be greater or equal than 1, right? So that the price is the maximum price is then x equal to 1.
Why
So then,
should it be greater or equal to 1?
yes, that's my question to you. Why it should be greater or equal to 1, but not just equal to 1?
Shouldn't it be more than or equal to 2/3?
Now this one, yeah, I know. So this part.
Yes. Why 1?
And you mean by 1 this? Because in total. So in total, it's supposed to be greater or equal than 1. It's maximum. It's by our setup, so not setup, the task, right? The task says, so find such conditions on A and V that maximum price will be then x hat equal to 1. Yeah, let's come back to our picture. Yeah, that previously we have such a graph that it goes like that, and then you have maximum in 2/3. Then we made some transformations with it. Probably it looks like kind of the same. So that now we know that we are in maximum in that point. So that let me actually derive. So we just derived the first order conditions, right? So then again, I will write the function here is ax hat there was plus v 1 minus x hat squared. What will be if x equal to 0? We're still in 0. So the starting point is 0.
Excuse me.
What will...
If we solve this equation forward, I mean comparing to 1, I got the answer that A should be greater or equal than V.
That's correct. We will do it in a second, but Now let me explain you why we need it greater or equal. So then probably we will start from the same point and then move somehow like that. Yes, so you need to move it to the right such that your maximum is, okay, so this is 1. So your maximum is in 1. So, but what will happen if I will do it such I have it somewhere here? So that this is our point x hat star. We by star denote this one. So then what will be the maximum price available to on the platform? So this is the price. If the solution to our equation is above 1, what will be the maximum price?
Corresponding to the maximum x.
So this one you mean? So this? Do you remember how our consumers distributed?
Yes, so
So
they are
they,
distributed from 0 to 1.
so you cannot make it greater than 1, right?
Yes.
So you always have the number of consumers so that if we are in 1, so that whose join is this one. And even if the solution is above, even if solution is greater, you cannot make the agent more than 1. So even if this price which we calculate from our equation is above and indifferent consumer is above the 1, so then everyone still will join, but the corresponding price will be lower, right? Because you cannot make more consumers than you already have. Everyone is already connected. That's why any x which is above, which is from 1 and to infinity, is okay for us. Anyway, the maximum price will be in 1 on our graph. So that's why we put here greater or equal than 1. So then let me solve this.
So just if we have the solution that this x should be, I don't know, some millions, we just
Yeah.
draw this function, draw this graph, well, calculate it, and
Mm-hmm.
just find its meaning in x equal to 1, because we just don't have more consumers. So they are all going to join, but still the price will be higher than it would have been if our calculated x were less, right?
Right. The price will be a bit lower
Mm-hmm.
because, yeah, there is not enough consumers. So that everyone is connected and the x hat equals to 1 because there is no more consumers. And then the corresponding price from the graph.
Okay.
Because if you want to increase the price, you're supposed to increase the number of users to satisfy the equilibrium, which is impossible. Okay, let it be. Should it
Does
free?
does that mean that all the equilibriums are, well, all the curves which have maximum not at 1, well, x equal to 1, but have maximums like x equal to 100 per million. They are irrational for the platform.
Now that's just a form of our utility function, so that because this curve is defined by the form of the utility function, yes, so that we this one. So when they equalize the indifferent adjunct to his zero option, outside option, and then we define this this curve. So then platform just doing the best given this curve is drawn, so that find here maximum profit. But now we are talking about prices. Profit is a bit different.
Okay.
So yeah, let me finish with this inequality, so that so it's positive and positive. So we can take the square. So it will be 1 plus 3a v greater or equal than 2 for 2 by 2 4, so that it's 3a greater or equal than 3v or a greater or equal than v. So yeah, so that's just a nice constraint without any numbers. And then that's the answer. Questions? Okay, then let's move to the last question in that problem. So again, we considering the production and assuming the zero cost. So that is 0. And they have the monopoly platform. Yeah, now it's monopoly. And what function of all? So then we are interested in probably price and n. What is the price? What is the n corresponding to this price? Yeah, and they again assuming a equals to 0 and v equals to 1. Well, again, our equation, the price of x is whatever it was. It was 1 minus x squared. So then what is the profit which firm maximize?
So this price multiplied by 1 more x, which is equal to n.
If n equals to x in this case. Yeah, here will be n multiplied by 0 because costs are 0. But what is n here? So we remember that utility is increasing in x. So that everyone who has indifferent x and above will join the platform. So then in our case, it's 1 minus x hat. Right?
Yeah.
Okay. So then we need to maximize 1 minus x squared x squared. Yeah, instead of considering price, let's consider x so that we will maximize this by indirectly choosing x hat. So then let's take the first order conditions. Now what is this? So 2x hat, 1 minus x squared minus 2 1 minus x squared. So the first solution is x equal to 0, right? So then we can divide by it. If x is not 0, then the next solution is x equal to 1, right? We can divide by this as well. So that let's divide by x and by 1 minus x. So what is the left is, and by 2 as well. So that will be 1 minus x minus x equal to 0. So and the first solution is 1/2. Well, am I right?
Yes,
Looks like
and which of those roots like has two roots in it?
right roots. We have the third power
Ah,
in
yeah,
total.
I see. Okay,
No, it's the fourth here.
it's the fourth there, but after the taking of
Yeah, after that,
derivatives
taking the
is yes.
it's good.
Okay.
So then the price, which depends on not the price, the profit is 1 minus x hat squared x squared. And if we put 0, we receive 0. If we put 1, we receive 0 as well. So then what we receive, we will put 1/2. So it will be 1/4 multiply 1/4, right? So it's 1/6. So that's the profit. What is the price? So who has already calculated? So the price is just that 1 minus x hat squared. And what is this?
like 1/8.
Yes, 1 over 8. And what is n?
One half anyway.
Yeah, n is 1/2. Great. So, well, we are done here. Any questions about the profit maximization? Okay, you should be careful with this that we maximize it with respect to x, not with respect to p. So we have the equation which connects them, and then we can do this. But then we're supposed to be very accurate with different solutions, right? Because we can see that the profit which maximize our profit, sorry, not profit, the price which maximize our profit is unique. So if you will try to reverse it and then you take the derivative, it's supposed to be the one solution. So then you need to check these 3 points which we found and pick the correct one. Then, unless you have any questions about first problem, let's do problem.
About the last idea, what should we be cautious about?
So that then you maximize with respect to x, you can find several solutions. So not solutions for your first order condition equation. So it's x0, x1, x1 half, but that's not all of them bring us the maximum profit, right?
Yeah,
So that
okay.
you check and then pick the correct one. So before we move to the problem 2, let me remind you the problem from our lesson, from our lecture. So we considered the one-side platform. So the utility was, what was the utility there in the class? Who remember?
Well, we had several variants, but our last one was like theta I plus new and expected and zero otherwise, I guess it.
Yeah.
And we had a restriction that 1 should be greater than should be greater than new, and new should be greater than 0.
Yes, and theta is distributed uniformly on 0 and 1.
Yes.
So then today we will talk a bit more about social welfare. So what is the social welfare? Generally.
In this problem, it should be the total sum of profits of the firm and the utilities of the customers. something like that.
Yes, you're right. So if you're talking about the social welfare as a function of the number of the consumers which will join the platform. So you remember that once again, so that if we will draw the distribution of I from 0 to 1, remember there was the indifferent teeter head. And who is joining the market? Once again, so the utility is increasing or decreasing in theta?
Increasing.
So
So
who will join?
those who are to the right from the theta.
Yes, so n will be equal to 1 minus theta hat. So that this adjoin, so they need to take the integral from 1 minus, no, from, yeah, 1 minus n, which is theta, to 1. All across the utilities who join the market. And so they need to integrate this theta I plus nu n. Okay. So then we will need the PDF of uniform distribution of I and across all consumers.
Why we have this lower border of the integral like that?
Because the rest are not joined, right? Oh, you mean why I'm not integrating from theta hat?
Yes.
So because I want to receive the function depends on n. So I want to consider what is the social welfare depending on how much agents join the market.
But in this case, it should be yes, 1 minus n. Yes, okay.
Yes, so and then so that's the positive price, the positive side of the of
I-
So you lost me?
I guess Yandex Telemos just lost everyone.
Okay, so it's reconnection.
Hope so. At some point, I was just unable to hear you and to turn on my micro as well. And do I
Yeah,
understand it correctly that there are only two of us and there is no your second account, right?
right.
Oh, I will write to everyone else to reconnect.
Okay. So now you can you can see
Yes,
me. Great, I reconnected, so probably we'll need to reconnect. So maybe it's maximum time for Telemost to do so.
it wasn't stated anywhere, so I guess it's just some technical problems with it.
Yes, well, for me, I have like two seminars for you and then for two seminars for other group. So I just put the one meeting there for how much? 5 hours? So that 5.5. And Telemost said me nothing, so. And now we're gonna see. Okay. So we were 7, I guess.
Yes, 7 or 6.
Well, okay, let me continue. So that's positive, and then we need to calculate the price which is paid by every one consumer. So again, we need to integrate across consumers. Right, and this is just across consumers, so just PDF. And then
Why there is a minus?
because you pay price, right? Your
Ah,
consumer.
yeah, okay.
This consumers. And then we doing the surplus of the platform. So then platform receive the price from anyone who joined. So it's exactly the same, but with another sign. And then the platform pays the cost. The cost a constant and equals to C. Okay, that's platform. So then
And yeah,
huh?
sorry. And in the first component, we can't put those variables out of the integral because theta depends on I, right?
Yeah, theta depends on I, but the rest we can.
Mm-hmm. Okay, well, if we want to, yeah.
Yeah, just to be more understandable. So then we can cross the price because it's just the redistribution of welfare. It's, so if you pay the price from the consumers to platform, in total there is no change. That's why it goes out. So and what we are left is, so let's integrate the theta from 1 minus n to 1. So what it will be. So let me rewrite it here. How do we need to think about this?
Well, in our case, it should be easy because we have a uniform distribution.
Right.
It should be just theta. No?
No, that's like let me draw the picture. So you take it from 1 minus n to 1, and you kind of you have your uniform distribution, right? But you take it. So what is then you take the x and multiply by PDF and integrate for some in some area. It's like you take the mean of this variable on this interval. So it will be the middle one. Should be. Yeah, or you can just integrate, because PDF is 1, so this is just theta square over 2 from 1 minus n to n, so which is n minus n squared minus, sorry, no, the opposite. N squared minus 1 minus n squared over half. And this is 2n minus 1 over half, right? I think so. So is it really between? So it, okay. So that's the answer for this. Then we have the integration. What we have, Vn and then integral. So then we have 1 minus 1 minus n. This is just the number of consumers. It's n, finally. And then we have minus c and the same, 1 minus 1 minus n. So then let me rewrite. So that's n minus
And
1/2.
we just used the property of uniformal distribution, right? For this.
Yeah, the PDF of uniform
Yes.
distribution from 0 to 1 is just 1. So then we can integrate. Then what is here is Vn squared minus Cn. So let me check the results, if I'm right. Not really. Oh yeah, one mistake here. Sorry guys, here supposed to be from 1 minus n to 1, right? And then here will be 1 squared. And what is the answer? It will be 2n minus n squared. So then we will have n minus 1/2 n squared here. So that's v minus 1/2 n squared plus 1 minus Cn. So this is how welfare depends on the number of the users who connected to the platform. And what if I'm a social planner and I want to maximize the welfare and I want to calculate the optimal number of users connected to the platform. What should I do?
Just take another first order condition.
Yes. So what is this? This is 2v minus 1n plus 1 minus c. And if we equalize it to 0, what is for social welfare is good, is then we have n equal to 1 minus c over 1 minus 2v. So this is the social welfare. And do you remember what was the monopoly n from our lecture?
A little bit less than 1/2.
Yeah, that's true. That was 1/2 multiplied by something. So that was 1 minus c divided 1 minus v. So then let's compare these two. Which one is greater? Yeah, remember that 1 greater than c greater than v greater than 0. And here we have one.
Welfare should be greater because the denominator is less.
Yes, so since here we have 2 minus 2v and here they have 1 minus 2v, the social welfare number of users will be greater than monopoly 1. So what is optimal for social welfare is greater than what is monopoly do. So then we can say that monopoly is not probably the best market, maybe. And yeah. So then let's move to maybe any questions here?
Well,
Is
I
it
guess
surprising for you?
not really.
And let's move to the problem 2 finally. So that was just to show you how to deal with welfare function and what we are interested in and what we are maximizing. So now let's consider n agents so that we have theta first greater than theta 2 and so on to theta n. So this is the types of the agent. So that any agent from first to n has a own type, and the utility is defined as theta I plus some function n minus p.
It's the second problem, right?
Right. So the first we are finished. So we have finished the first problem, so it's the second. Yeah. So we have price, we have network, effect function f, n, so which is not specified here yet. And we will consider the social welfare. So the welfare function, which depends on n now, is the sum of those who join. Here is from some I from first to n. Yes, since our θ1 is greater than θ2 and so on, then the first will join firstly because they have more utility from joining the platform. That's why we will sum up from first to some n. And so we will sum, not integrate, because we have discrete number of users. So this is the social welfare function. And the first question is to prove the following result, that if Fn is increasing, then the Nash equilibrium number of users will be lower than the number that maximizes the total surplus. And other way around. So if we function f is decreasing, then the number of users who maximize the total surplus will be greater. So any idea how to think about it?
Well,
So on once,
we can still draw this picture maybe. So like some theta, and if f is increasing by n, it means that all whose are to the right will buy and to the left won't buy. And if f is decreasing by n, it will be vice versa.
not really. And maybe no, it depends on theta, not n. N is number now, 1, 2, 3, 4, 5. So we need to compare the number of users who will be joined. So firstly, let's say that who joined the platform in Nash equilibrium. Or let me reformulate the question. Who is the last agent who joined the market?
Indifferent by, well, he well, we don't know does he join or not, but we know that he's the bot actually.
Yeah, so what we can write, so that for this agent I who is indifferent, let's define, not indifferent, so that not hat on the theta, but let me draw the I hat here. So that he will be, let's say he joined the market, what his utility will be.
So we can't do as easy as we did before. So we actually matter. Does he join or doesn't he? So we'll have like two parallel universes for this.
So now, for example, let's say that this one is the agent who joined the last, and then next doesn't join. So what I can write about his utility? So that he is the I, and then we know that the number of consumers is I. Then, so his utility is positive, right?
Yes. strictly
Not
positive?
at least not negative.
Shouldn't
But
it?
then we know. Hmm?
Shouldn't it be strictly positive because we don't have a continuum of consumers now, and it actually matters whether he joins or not. So we can't use
So
those.
it could be positive. If we are talking about Nash equilibrium, it doesn't matter.
Mm.
But what do we know about the next one? He doesn't join. So if we will take theta with I hat but plus 1 minus b, and then if he will join, the number of users will be I hat plus 1. What is his utility?
Strictly negative.
Yes, so then we have these two. Hmm. These two equations, right? So then that's about the last who join in Nash equilibrium. But what about social welfare? So that's from Nash equilibrium side. So our welfare function is sum from 1 to write it like from 1 to n, and then we have theta I minus b plus fn. So what does it mean that some number n of join the market? So that's okay. Let me still use the I hat. What does it mean that I hat is the last one who joined the market in terms of maximum social welfare?
Like the next one will decrease social welfare.
Right. So that now they have that sum from I1 to E hat from EI minus P plus Fi hat, because now the number is I hat, will be greater than sum if I will join the next one, which is I hat plus 1. And here we will have I hat plus 1. So now let's consider this inequality. So this inequality defines the social welfare maximization. So can I open the brackets here and sum? So let me do this. So from the left side, I have the sum of theta from 1 to I hat. Theta. Then I have price multiplied by I hat, because if I just sum up from I to I hat, multiply by price, price is equal to everyone. Then I have the function which corresponds to our network effects. But it depends on total number, so I can take it out of the sum as well. So it will be I hat and then function of I hat. And what I have on the right side, I have sum of theta from 1 to I hat plus 1. I have the same price, but now multiply by I plus 1. And then I have,
Excuse me.
yes.
And can we easily do this for function of I hat? So can we just like open the sum this way? It has a
So the
dependency on I.
so I is from first one to I hat, and I hat is a fixed number, right? It's the last agent who joined. So the index I changed from first one to the last one who joined, which is I hat. So that function of I hat is the constant in terms of this sum.
Ah,
So we can
yes,
take it
okay.
out. So now let's see what we can cross. So the price and this goes out. And then any theta will be the same, except here will be the theta I hat plus 1, the last one, right? The rest will be the same. So what we have that what we have theta, no, theta is out, so that which is not out is I function of I hat. Then on the right side we have theta I hat plus 1 minus price. And then here will be plus f I hat plus 1 and plus I hat f I hat plus 1. So then what is this?
Why is it I hat plus 1 in the function? Shouldn't be just
Because they take it from the second row.
and from the first row it should be 1. Yes, this one.
Yes, it's on the left side.
Ah, yeah, sorry. It's just the utility of one who buys. It's like the utility of uh, I had plus one, no?
Yes, it's the utility of the next guy who potentially can join. Right, so then we can write it on the left. So that's the utility. And that's supposed to be lower than I hat multiply by f I hat minus f I hat plus 1. So, and what we can say about this? So if f increasing, this is less than 0. If f decreasing, then this is greater than 0. Right? Because we move the argument from I hat to I plus 1, I hat plus 1. So the I hat is positive, so then everything is on negative or positive depending on if f is increasing or decreasing. So then let's stop with this and come back to our comparison for Nash equilibrium. What we remember for next guy who is not joining, we have this inequality. So let me copy it.
Excuse me. If f is increasing, we should have less than zero, right? And
Right.
if it is decreasing, we should have more than zero.
Mm-hmm.
Yeah. Okay.
So this inequality is for social welfare. So then from Nash equilibrium, we have the same, right? So, and then you compare these two. So this is the social welfare, and this is Nash equilibrium. So which restriction is more strict than function increasing and then function is decreasing? So the last equation define for us the Nash equilibrium. So and this gives us the I hat Nash equilibrium, and yeah, the first one gives us the I hat social welfare.
Does that mean that Nash equilibrium assumes that f is increasing by I?
Not necessary. So it could be everything for Nash equilibrium.
Mm. Well,
So what we compare here is the difference between social optimal and Nash equilibrium, depending on function which represents the network externalities.
well, Nash equilibrium is more strict.
Why?
Mm, because social welfare assumes that there could be two alternative variants. So it could be less than zero, it could be more than zero, but Nash equilibrium says that The left hand side should be less than 0, and that's it.
Yeah. So then, so okay, we need to consider two cases here. If function fn is increasing, right, then this is negative, right? And so you have restriction that your utility function is less than something negative, which is more strict than if you have your utility function less than 0. So it can be something else, right? So that you already satisfied the second, then it's negative. So for example, if you have x equal less than minus 10, and you have x less than 0. So then you satisfy the first one, you already satisfied the second one as well.
So the second one is less strict.
Yes. So then in Nash equilibrium, we will have more consumers who join the market. So in Nash equilibrium, right, now we need to show the opposite. It's increasing, then the Nash equilibrium will be lower. Is it true? Never make the mistake.
Well, even if we consider the case when f is decreasing by I, we still will get the larger area in Nash equilibrium, because it says that it should be just less than 0, while our restriction will say that it will be possibly more than not 0, but I don't know, 0 plus epsilon.
So then it could be x is more than 10 and x is
More than.
so less than 10, sorry, less than 10 and less than 0. So then the first one gives you more area, right? So then, okay, let me think about it. So this is the guy who does not join because his utility is negative. So then, so when they have the utility of guy I, and if I joins, so it means that this increasing. So then the utility was decreasing of I somehow, and then we find those who join and who not to join. So let me draw it like that. So this was I, and this was I had plus 1, who is not joined. And then we have this 0. And now they have the comparison. If function is increasing, that you're supposed to be less than something negative if you are increasing. Well, I opened somewhere here. It's wrongly, but I'm not sure.
About increasing and decreasing, it seems logical.
Yeah, so if it's minus 10 here, So then you probably can connect more agents, right? Because right now you compare here, so that this I, so that's I had
Are you now
social welfare
describing increasing f or decreasing? Because due to
increasing.
in
Yeah,
this
if you're
case
increasing,
you have
yeah,
another graph, your function is
right.
decreasing.
Yes, my function is decreasing, the social one. That means that this is negative, right?
Yes.
This is negative, then we need to compare the last one is with minus 10, not with 0, with minus something. So which means that the utility, the total utility of the last guy, now compared not with 0 as in Nash equilibrium, but with something negative. Yes, because this is the utility. Which color use? No. So this is the utility of the last guy who join or who doesn't join. The first one who doesn't join.
So if f is increasing, the utility is decreasing by I. Just what to have on your axis? I and what? F or U?
You. So because your theta is decreasing, right? From
Not
theta is
t,
decreasing in I.
not theta. F. It's not the same.
No, f is increasing in n, but
Ah, yes.
theta is decreasing because it's lower and lower and lower. So that we assume that those who join has some positive utility in the beginning, but then it can be the indifferent guy or those who is join, and then the next one doesn't join.
We just didn't discuss the theta increasing or decreasing. That's why it's a little bit confusing.
Okay, well, it was by assumption in the beginning, so yeah. So that the theta is,
Okay, so the vertical axis is theta or it's U.
no, it's total U.
It's totally U. Okay.
So we know that there will be some indifferent guy or the last one who join and then next doesn't join. So that's about Nash equilibrium if we compare with 0. So and if the social welfare and function is increasing, then you have to compare with something negative, and you can join more users. So then the Nash equilibrium will be lower than number of social welfare. And by the same logic, if n is decreasing, then you need to compare with something positive. For example, plus 10. And then you will have it here. So that will be, it was blue. Right, this will be I had social welfare and plus 1 as well. So that's one, the last who join, and the next who doesn't join here. So then in Nash equilibrium, we will be greater than social welfare.
Could you please show the last graph? So it will be less than 0, right?
What? Less than 0?
So when Fn decreases, then what?
So then Fn decreases. This is positive, right?
Yeah.
So then we compare our utility with something positive. So this means that something positive is here, and the one last guy who joined is here.
Mm-hmm.
Next one not joining because his utility is lower than something positive. And this gives us that the last who joins here is less than the last who joins in the Nash equilibrium.
Yes, okay.
Well, so I think I will leave the last two questions to your home. So consider it at home. So the second one is about why it happens such that with social function connecting to externalities, and the last one just to calculate the example.
Could you please show the case of decreasing one more time? I mean, a little bit up.
Okay.
And then I of Nash is what? This part.
So I of Nash you always compare with 0.
Yeah.
So it's the same in both cases. So it doesn't matter, so that you always compare with 0. But if f is decreasing, so then this difference is positive, right? Because then you move to the +1, so you get something lower. The
Yes.
difference is positive. So then we need to compare our utility for the last guy with something positive. So then we are going back to graph. And so something positive line is above, and intersection is now closer to the beginning than if it will be with 0.
Mm-hmm. And so
Okay, maybe, yeah.
and in this case, this intersection, so I of Nash, it should be greater than with 0 or less.
No, greater than social welfare.
So social welfare is the intersection of pink and 0, right? No?
No, in something positive. Okay, let me draw it once again. So then this is our utility of guy I, depending on I. And then we have I. So they know that there will be some guy who will be different I Nash equilibrium. And the next wouldn't join. So then I will draw the function such that so the function is positive, and then after Nash equilibrium it's negative. If I compare with 0, this is the 0 line. Then now if I'm talking about social welfare, I will have some additional positive or negative term with which to compare. If the function is decreasing, so I need to compare with something positive. Then the comparison point is here, and the corresponding G social welfare is here. So then f is f. So if f is increasing, I need to compare with something negative. An intersection point is here. Yes, and E social welfare somewhere here. Right, depending on if I have increasing or decreasing function, the I social welfare can be can be greater than at Nash equilibrium or lower. Is it more understandable?
Yes, thank
Okay. So then time is out, and that's it for our exercise session today. And if you don't have any questions, then see you next week on the lecture.
you. Yes, okay. Thank you. And
Bye.
and about
Huh?
yeah, sorry. About two last points.
So, like, please do it at home, and then we will slightly discuss it briefly in next exercise session.
Yes, okay. Thank you. Goodbye.
Bye.